Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Sir Joseph or Mr. Explicit. Please, as you are watching this video, endeavor to subscribe, like, share and comment. In today's video, I'm discussing physics, that is a topic called fundamental and derived quantities. Fundamental and derived quantities. Now we have two words here, derived and what? Fundamental. If something is fundamental, it means it is what? It is rudiment. It is very, very important. All right. Now, fundamental quantities are quantities that are independent or they do not depend on other quantities, which means that they can exist alone. I'll take it again. Fundamental quantities are quantities that are independent or they do not depend on other quantities. That means they can exist alone. So I shall be giving you the examples of fundamental quantities we have in physics. And John will ask you which of the following is fundamental quantity. Please, it's very important you carefully pick your answer. So fundamental quantities, I said, are quantities that are independent or that do not depend on other quantities, which means that they can exist alone. Now, what are some examples of fundamental quantities? They are mass. They are mass, and mass is measured in kilogram. That is kg. All right, mass is measured in kilogram, or in other words, you say the SI unit is also in kilogram. All right. You have length. Length is measured in what? Meters. That is small letter m. All right, and then you have time. Time is measured in seconds. Like small letter what? S. Other fundamental quantities are temperature. Temperature, the SI unit is measured in what? Kelvin. That is K. All right, you now have a current. Current is measured in ampere. Ampere, that is A. You now have luminous intensity. Luminous intensity is measured in candela. Luminous intensity is measured in candela. You now have or you say quantity of substance. Quantity of substance is measured in what? Moles. That is small letter what? M. Fundamental quantities are quantities that are independent or they do not depend on other quantities, which means that they can exist alone. Now, we have several examples of fundamental quantities. Mass measured in kilogram, length measured in meters, time measured in seconds, temperature measured in Kelvin, current measured in ampere, luminous intensity measured in candela, quantity of substance measured in what? Mole. Please take note, do not mix them up. Let's answer this question. Which of the following is not a fundamental unit? They gave I Kelvin, I Newton, I second, and IV radian. Please, please, and please. Newton and radian are not fundamental quantities. According to the information given, Kelvin and second are the only fundamental quantities we have here. So which means that the answer of this question is I and I. Where is it? I and I. So A becomes the answer. Please, we are done with that. So these are examples of fundamental quantities. So the next one we're looking at are derived quantities. As the name implies, derived quantities. Derived quantities. What are derived quantities? Derived quantities are quantities that depend on the fundamental quantities, all right? That is to say that they are gotten from the fundamental quantities. I take it again. Derived quantities are quantities that are dependent on the fundamental quantities, and they are gotten or derived from them by multiplication and division. It is never by subtraction and addition. No, it is always by multiplication and what? Addition. Please take note of that. It is very, very important. Now, based on what we've said, we have numerous examples of derived quantities. Numerous, okay? We have a volume. Volume is measured in L cubed. That is L times what? L. We have area. Area is L times L. That is equals what? L squared. All right. You have density. Density is mass over volume. All right. Pressure and stress have the same units. They have the same formula, having the same dimension as well. If they have the same formula, it means that they have the same dimension. All right. So it is force over area. That is what? Pressure and stress. Torque. Work done. And moment. Torque, work done, moment. They all have their formula as force times distance. So which means that they have the same dimension. Boyle's law as well. Boyle's law has the same dimension as torque, moment, and what? Work done. It is very important. Now, this one I just wrote: pressure, stress, and Young modulus. That is Ym. Pressure, stress, and Young modulus have the same dimension. Torque, work done, Boyle's law, moment have the same dimension. Formula: force times distance. They'll ask you which of the following has the same dimension as work done. If you are not giving this, you'll be giving Boyle's law. Please take note of that. It is very important. Now, apart from this one we've written, we also have speed. Speed/velocity, which is giving us what? Distance over what? Time. The difference between speed and velocity is that speed is a scalar quantity while velocity is a vector quantity, alright? Please take note of that. You now have acceleration. Acceleration is defined as what? Change in velocity per unit what? Time, alright? So we are still going, we have not finished everything. We now have a moment. Moment is giving us force times, impulse. Impulse is giving us what? Force times time. Alright, the momentum is giving us what? The product of mass and velocity. The product of mass and velocity. Please, impulse and moment have the same dimension. That's why they'll tell you that change in impulse is equals what? Change in momentum. Please take note of that. It is very, very important. That is Newton's second law of what? Motion. Impulse and momentum have the same dimension. You now have power. Power is giving us work done over what? Time. The rate at which work is done is called what? Power. Now, power is giving us what? Work done over time. You now also have force. Force is mass times acceleration. Please take note of this formula as well. Very, very important. You now also have electromotive force. That is EMF. The EMF of a battery means the work done. It is the ratio of the work done over what? Charge, which is what? Alright, so work done, we said work done is force times distance. I'll say force times distance over charge. You are believing that charge is equals what? I times, that is I times what? C. I here means current, alright, then C is what? Time. Which means whenever I see charge, I put what? IC. Alright, so please take note of that. Alright, there is electromotive force can be defined as the work done in carrying a unit charge from a considerable point to another point. Alright, it is also defined as the work done in carrying a unit charge, alright, from a point of lower potential to a point of what? Higher potential. Alright, take note of that. So that is what? Electromotive force. What about magnetic flux? Magnetic flux. Magnetic flux is given as F times area over QV. Alright, F times area over QV. The V here connotes what? The velocity. Right, F is force, A is area, and Q is what? Charge, IC. Alright, you know that I is meant, that is current is measured in what? Ampere. Alright, so please, these are some examples we have. We have numerous examples of derived quantities. Don't forget that mass, length, time, temperature, current, luminous intensity, and quantity of substance are all fundamental quantities. Then other quantities that you have are called derived quantities. So I'll be doing for the one we have on the board. Then in our next class we shall be taking all these ones that I've done, or these ones already have their formulas written on the board. But meanwhile, let us trash this question. Now, they said the dimension of power is A, whatever. Power is giving us work done over what? Time. You will also agree with me that power is equals work done is force times what? Distance. Alright, over time. Let me take it bit by bit. You know that force is mass times acceleration. So times this what? Distance over what? Time. Please, the three most acceptable fundamental quantities are kilogram, length, and what? Time. The three most accepted or acceptable fundamental quantities are mass, length, and what? Time. Alright? In terms of units, we make use of kilogram, meters, and what? Seconds. But in terms of dimension, we make use of the first alphabet that begins the word. Mass is written as this. So we are picking what? Big letter M. Alright, length. So we are picking big letter L. Then time, we are picking big letter what? T. M, L, T. So based on what I've said so far, power becomes, mass here is big letter M. Acceleration is LT minus 2. Yes, let me explain how I got this. Now let me put it, the acceleration is what? Velocity over what? Time. And velocity on its own is distance over what? Time. If this stick goes up, it becomes what? LT minus what? 1. If this stick goes up, it becomes what? Minus 1. Alright, so the dimension of velocity is LT raised to what? Minus 1. Alright, so which means whenever I say velocity, I'll put LT minus 1. So the LT minus 1 over T, right? So if this thing goes up, it becomes minus what? 1. You see that? So it means, let me express it. Therefore, acceleration is LC minus 1 over what? T. So you have LC. If this one goes up, it becomes minus 1, so minus what? 1, alright? So minus 1 minus 1 is what? Minus 2. So that is how I got minus 2 as what? My acceleration. Then you now have distance, which is what? L, right? Over time, big letter T. So what do we have now? Food is almost getting ready. I have big letter M. L times L, L squared. Now we're having minus 2 here. As soon as this thing goes up, it becomes minus what? 1, right? That is minus what? 3. So what we have here is, this becomes the answer, ml squared t minus 3. In some cases, you will see they will do like this. mx ly tz. They will be asking you, what does x, what does y, and what does z stand for? So, based on what I have here, there's an invisible plus 1 here. Therefore, x is plus 1, or just write as what? 1. Then, you have y. What is taking the position of y? 2. So, y is 2. What about z? So, z is what? Minus 3. So, at this point, we're going to day. If you have learned something in today's video, please endeavor to subscribe, like, share, and comment. Do have a wonderful day.